Here is our 19.4 worksheet, and we have a problem that's very similar to the last one that I just did in our notes for 19.4. We are being asked to determine the rate law and also the rate constant for the following reactions. So first of all, looking at the reaction, seeing that we have reactants A and B, I know that our rate law is going to have this general form, K, A to the X, B to the Y, and our goal when we're determining a rate law, our goal is to figure out the value of X and Y. And so also in this problem, we have three sets of data, 1, 2, 3. And these are the three sets of data that we have available to us to help us figure out what the rate law is. So to solve for X, let's make a note of that. To solve for X, we are looking for two reactions or two sets of data. We want, in our two sets of data, we want A to change in our two sets of data. We want to be able to see the change in A and how it affects the rate. And we also want B to not change in our two sets of data. So we want to find two sets of data where B does not change. That's going to be data set 1 and data set 2. And can we determine easily how this works? So if we compare from 1 to 3, so when we go from reaction number 1 to reaction number 3, the concentration of A is doubled from 1.5 to 3. 1.5 to 3, which is doubling, so we're multiplying it by 2. And when we look at our rates for those same reactions, the rate goes from 0.32 to 0.64. So the rate also doubles. When you double the concentration and it also doubles the rate, that's a direct relationship. That means that the exponent for A is 1. So we know that our exponent for A is 1. We know that that's a first order reaction. So we've got one of them figured out. Let's take a look at our next challenge. Now we are going to solve for Y. And to solve for Y, again, we're looking for two sets of data. This time we want B to change because we want to see how changing B affects the rate, but we want A to not change. So what are we looking for here? We're looking for data where A does not change. We've got this right here. This one maybe is a little bit trickier. So what do we see? We see that we're going from B equals 1.5. So this is going to be data set 1 to data set 2. Those are the two we're comparing. The concentration of B goes from 1.5 to 2.5. And that's not an easy number. That's not like it's doubled or it's quadrupled or tripled. It's something, but it's not an easy number. We're going to have to think about that. What about our rate? Our rate is 0.32 and it goes to 0.32. Oh, so the rate doesn't change at all. The rate does not change. When the rate does not change, that means that B has no effect. The concentration of B has no effect on the rate of the reaction. And that no effect, that is the 0th order reaction. So our rate law for this reaction is K, A, B to the 0. Now you might be saying, could I just write Ka? Because B to the 0 is always going to be 1. Would that be okay? And sure, I mean, I'm fine with that. Although conventionally we don't do that because typically in the rate law, we do show every single one of the reactants. They all get their spot in the rate law. So by including that B to the 0, you're communicating that, yeah, I know B is a reactant, but it doesn't have any kind of effect on the rate. So we've got our rate law figured out. Now the next thing that we need to do is figure out the rate constant. That's going to be K. How do we go about solving for K? Well, this is now just an algebra problem. We just need to know a rate, an A, and a B, plug it in and solve for K. Come up here, we have a lot of data available to us. Which one should we use? Which rate, which A, which B? it doesn't matter, and it won't matter. You can use any one of them, and you could actually try this 3 different times. You're going to get the same value of rate every time. So we can use, to solve for K, use any data set. Your choice, 1 or 2 or 3. I will use dataset 3 because I'm going to scroll up, and dataset 3 is the only one I can still see. So for dataset 3, the rate is 0.640. The units of that were molarity per second. K is what we're trying to figure out. A is 3.0 molar. And that is to the 1. And B is 1.5 molar, and that is to the 0, which is just going to become 1. So K is 0.640 molarity per second over 3 molarity. And our value of K will be 0.64 divided by 3. Our value of K is 0.213, and the unit is 1 over second, or second to the negative 1. So there is the value of K. And there it is. This particular question has 2 answers. Here is one answer, what is the rate law? And here is the other answer, what is the value of the rate constant K? Now, hopefully you're feeling a little less uncomfortable with this, but I'm sure you still need practice, so let's do some ALEKS problems.